Now let's move on to question 2 of the AHS paper. What we have over here, basically they are just indices, so you need to be able to play around with indices and definitely know your laws of indices very well. So we are given this equation and we are asked to show this equation over here. So I'm just going to copy down this equation over here, and next what I'm going to do, right, is I'm going to bring this 3 to the power of 2x. I'm going to divide it over to the right hand side. So we get 13 equals to 5 to the power of 3x over 3 to the power of 2x. Okay, and I can write the right hand side as 5 to the power of 3 whole thing to the power of x divided by 3 to the power of 2 whole thing to the power of x. In that case, we can clearly see that the right hand side, I'm going to write it on the left now. Okay, so 5 to the power of 3 over here is 125, and 3 to the power of 2 is 9. So then we can say that because this is power x, this is also a power x, so I'm going to write a power x over here, and this equals to 13. Okay, and we are done. Next, the question asks us to find the value of x. Now, if you are asked to find the value of x, right, where this x, which is the unknown, is in the power, chances are you will need to use logarithm. So over here, what we are going to do, again, I'm going to copy down this equation over here. 125 divided by 9 whole thing to the power of x equals to 13. Now, in order to solve for an unknown where the unknown is in the exponent, you need to take logarithm of both sides. Whether you take the common logarithm LG or you take the natural logarithm ln on both sides, it doesn't matter. Here we will take the common logarithm on both sides, which is LG. So I'm going to take LG on both sides, which is over here, and I'm going to take LG on the right hand side, which is over here. Next, we can see that this, I can bring it down using the power law. So XLG 125 over 9. Now this equals to LG 13, correct? And what we can do over here essentially is to divide this over from the left hand side to the right hand side. We get x equals to LG 13 divided by LG 125 divided by 9. Yeah, and using a calculator, you can see that this x over here is approximately equals to 0.975, rounded off to the 3 significant figures. And then you are done. Basically, that's it. Okay, so next, we are going to move on to 2b. Again, this question involves logarithm as well. So we are asked to solve the equation log of 2x minus 1 to base x equals to log of 4 minus 5x to base x squared. So what I'm going to do over here, okay, for the right hand side is to do a change of base. Now for this type of question, the hard part about logarithm is the change of base law. Essentially, if you're able to choose the correct base using the change of base law, then you can solve the question effortlessly. So you need to be able to identify the right base to choose. So over here, let's choose base x for the change of base over here. So log of 2x minus 1 to base x. I'm not going to do anything to the left hand side, but for the right hand side, I'm going to do the change of base law. Over here, I'm going to choose the base to be x. So it will be log x 4 minus 5x over log x squared. And then we can see that over here, this denominator over here is actually 2. The reason being because log base x squared, I can bring the 2 down using the power law. So this is 2 log x to base x. In that case, we recognize that this is 1. So 2 times 1 equals to 2. So that's why this is 2. So I'm going to rewrite the equation. So this will be log base x 2x minus 1 equals to log base x 4 minus 5x over 2, right? So in that case, I am going to multiply this 2 over to the left hand side. So 2 log base x 2x minus 1 equals to log base x 4 minus 5x. Now I'm going to bring this over to the left hand side. We get 2 log base x 2x minus 1 minus log base x 4 minus 5x equals to 0. Now here we can use the laws of logarithm. So this is actually, now I'm going to just do a shortcut. I'm going to bring this 2 up, okay? So using the power law. Okay, let's not do the shortcut. So using the power law, I'm going to bring the 2 up. So then this becomes 2x minus 1 log 2x minus 1 whole thing square to base x minus log base x 4 minus 5x equals to 0. So from here to here, I use the power law. Okay, I did not do anything to the other expressions. So now I use the laws of logarithm. We can see that this is equals to log base x 2x minus 1 whole thing square divided by 4 minus 5x. Now this is equals to 0, right? And remember logarithm. So if we have log base 3 to 9, this is equals to 2 because 3 to the power of 2 equals to 9. So this is an example to understand what I'm going to do next. So then x to the power of 0 equals to this, correct? So in that case, x to the power of 0 equals to this expression over here, in which x to the power of 0 is actually 1. So 1 equals to 2x minus 1 whole thing square divided by 4 minus 5x. Now we're going to multiply this over. So 4 minus 5x equals to bracket 2x minus 1 whole thing square. Now this simplifies to 4 minus 5x equals to 4x square minus 4x plus 1, which means that this is actually 4x squared plus x minus 3 equals to 0. Factorizing this, we get 4x minus 3, x plus 1 equals to 0. Solving, we get x equals to 3 over 4, or x equals to minus 1. Now, minus 1, there's no answer over here. Okay, well, that's because when you substitute minus 1 in here, right? Remember when you solve this type of logarithmic equations, similar to question number 1, you will need to substitute your final answers back into the original equation to check the validity of your final answers. Okay, so if I'm going to substitute x equals to minus 1 in the original equation over here, you realize that this will be 2 times minus 1, which is equals to minus 3. Now, this value cannot be negative. Okay, that is why here I will write it as no answer. Okay, so what about 3 over 4? Now 3 over 4 is okay because 2 times 3 over 4 minus 1 is actually equals to 0.5, or that's positive, that's good. And what about the value over here? Okay, so 4 minus 5 times 3 over 4. Now this is equals to 4 minus 15 over 4. Now this is actually equals to 1 over 4. Again, positive. So that's okay. And I want you to do your own verification. If you substitute 3 over 4 in here, you can see that the left hand side is indeed equals to the right hand side. And we are done with question number 2.